everyone. Before we start this session, I'll tell you to go through my videos on vectors. I'll share the link with you where I have explained vector from beginning, introduction to vector, dot product, cross product, all these I have explained. Today I am going to discuss with you some past year's question, and in this session I will be discussing past year's questions on JEE Main first. Let us start with this one. A is a non-zero vector such that projections on the vectors on these three vectors are all equal. Then a unit vector along A. See, before I start this question, I have to remind you the length of projection of a vector on another vector. This is the vector B and this one A. The length of projection is given by this length of perpendicular. AB is the vector, length of projection is LM. This LM going to be equal to AB into cos theta. Why? If you produce it in backward direction, then angle between the vector A and B be theta. Then here, if you draw perpendicular AR, then LM equal to AR, length of projection LM equal to AR, which is nothing but AB cos theta, and the vector is mod A cos theta, which is given by A dot B by mod B. Now, when I am going to use this condition that length of projection on three vectors here are equal, then the vector you assume as A is going to be A dot 2i minus G plus 2k, that divided by under root 2 square 1 square 2 square, that is 9, is going to be equal to A dot I plus 2j minus 2k divided by, again the length is root 9, which is equal to A dot k, that divided by 1. Understood? Because unit vector k has modulus equal to 1 only. Okay? So now if we take these two into consideration, it is going to be A dot 2i minus j plus 2k equal to A dot I plus 2j minus 2k. Okay? Now the vector A, is going to be like this. A dot, you take it on left side, two ways are there. If we stick to dot product, then you take, let A equal to, you assume that A vector equal to xi yj plus zk. So if you substitute there, it is going to be 2x minus y plus 2z equal to x plus 2y minus 2z. This is nothing but x minus 3y plus 4z equal to 0. Okay? This is number 1. And from the next condition, if you put it here, these two will give you A dot I plus 2j minus 2k, you already found, x plus 2y minus 2z equal to 3 into A dot k is going to be z. So therefore, x plus 2y minus 5j equal to 0. Okay? I wanted to do this sum with the help of dot product only. Now I got x, y, z in this manner. So let us get the relationship among these three variables. X minus 3y 4z, you write the coefficients here. X minus 3 4, 1 minus 3, and this is 1 2 minus 5, 1 minus 3. Wait a minute, this is going to be 1 2 minus 5, 1 and 2. I am going to use the method of cross multiplication which you have done probably in class 10. Now put the variable x over there, this is y and this is z. If you haven't done it before, no problem, you try to follow it. Put downward arrow, upward arrow, this manner. So this is going to be x by 15 minus 8, 7, downward arrow positive, upward negative. Y by 4 minus 5, that is 9. And z by 2 plus 3, that is 5. Okay? So you got the vector A in this form, x. You assume that this is equal to m. Then x is going to be what? 7m, y is 9m, and z is 5m. Okay? Now, the vector A is this, so required unit vector we have to find. The question is, find the unit vector along A. I got components of A in this form. So, required vector A cap is A divided by, this is the required vector, A equal to A by mod A, which is nothing but 7mi 9mj plus 5mk divided by under root of, this is 49m square, 81m square and 25m square. You can put plus minus over there. So 7i, m get cancelled, 9j and 5k divided by, this is 81 and 49, 130 and 155. Plus minus put over there. So now let us check which option is going to be correct. All are positive and this thing. Option D is going to be correct. This problem you can try with the help of cross product also. Because in the beginning, at this step, if we take it on the left side, then we get some relation between A and the vector dot product going to be 0. Right? And if you take these two, then also you get such a relation and you can show that A is perpendicular to two vectors. Then cross product helps a lot. It's better I show it to you. For this particular sum, if we don't use dot product after this, just have used the concept of projection of vectors. Now I will be doing it with the help of cross product only. Okay? How to use it? Let me show it to you. Now you take this way, that from these two you get A into this thing equal to 0. So this implies that E dot 2i minus I and minus 3j and 4k equal to 0. By using 1 and 2 we got this relation. And from here what you get? That E dot, from second and third, E dot I plus 2j minus 2k minus 3A dot k equal to 0, number 2. Okay? Now this one implies that A dot, just a minute. This one implies that if we take this on left side, I minus, no effect, here also no effect, and minus 2k minus 3k, so minus 5k equal to 0. Okay? This is your number 2. Now what do you observe there? That A is perpendicular to this vector, A is perpendicular to this vector. From 1 and 2 we observe that A is perpendicular to this one and A is perpendicular to this one. So A will be along, A is along, use the concept of cross product, A perpendicular to two vectors. So A is perpendicular to the vector, the plane containing these two vectors. So A should be along, say, B cross C. What we have taken as B? This one B and this one equal to C. So A is along B cross C. Find B cross C now. B cross C going to be I, J, K and 1, minus 3, 4, 1, 2, minus 5. So this is going to be 15 minus 8, that is 7, minus J into minus 9 plus K into 2 plus 3, 5. All of you know cross product. You must be prepared for dot product and cross product properly before you start JEE, before you start solving JEE paper. So this is going to be 7I plus 9J plus 5K. So A along B cross C. So required unit vector is going to be what? Required unit vector will be equal to A cap, which is nothing but A by mod A. Okay, A vector you got, so you substitute there, it will be 7I 9J 5K divided by under root 49 81 25. Same, you can always put plus minus over there. 7I 9J 5K, if instead of giving the answer in terms of plus sign minus given, that also you have to accept. So this is going to be plus minus 155. So the option D only correct. So I have explained how to solve a sum by using both the concept of dot product and cross product, either dot product only or cross product only, or if at any stage you find that cross product going to be convenient, you go by that. Clear? For this one, consider two vectors, angle between them given. One vector has one unknown over there, lambda. U has nothing unknown. Angle between them is given. So this lambda can be found if we use angle between two vectors. Can be done by both dot product and cross product again. Let us approach with dot product first. And it is given V equal to V1 plus V2. So let us apply this concept first. Angle between them is given by this. So cos theta, if U and V are two vectors, U dot V is going to be equal to mod U mod V cos theta, you know. So here cos theta, theta is this, cos inverse. So cos theta you can write U dot V by mod U mod V, and cos theta value is root 5 by 2 root 7, and U dot V is what? This is going to be 6 minus 1 by root 10 multiplied by 4 1 lambda square. I have taken modulus of U and V. So this is root 5 by 2 root 7 equal to 5 by root 10 root 5 plus lambda square. Now this is getting cancelled, root 5 will be remaining, cross multiply and make square. 10 into 5 plus lambda square going to be 4 into 35. Okay, so 10 into 5 plus lambda square equal to 140. These two getting cancelled. So lambda square 9. This implies lambda equal to plus minus 3. Lambda value, hope you have understood, they have given lambda greater than 0, so we will accept lambda equal to, as lambda greater than 0, you take lambda equal to 3 over there. Taking lambda equal to 3 as lambda greater than 0, we can write the vector u now. V1 parallel to u. No, u is given. V1 we can write. Here, V1 can be taken as some scalar multiple into u, isn't it? So, V1 vector, better to say, V1 vector is m into u, m into 3i minus g. And V2 vector is given perpendicular to u. What is V2 here? In this given relation, since V equal to V1 plus V2, therefore V2 vector going to be V minus V1. Writing capitals, you understand better. That's why. V minus V1. What is V over there? V is given 2i plus g, and lambda you got minus 3k. Okay. Now it is given that V2 is perpendicular to u. V2 vector will be actually V minus V1. So m into 3i minus g, which is nothing but 2 minus 3m into I plus 1 plus m into j minus 3 minus 3m. Wait a minute, m 2 minus 3m, 1 plus m. No, it is just minus 3k. Okay, 2i minus 3mi, j 1 plus m minus 3k minus 3k, just. Now it is given that in the problem it is given V2 is perpendicular to u, and u vector, you know what is u. U is what? 3i minus j. U is 3i minus j, and as V2 perpendicular to u, therefore V2 dot u going to be equal to 0. V2 is what? 2 minus 3m I cap m plus 1 j cap minus 3k cap dot u vector. 3i minus j dot 3i minus j equal to 0. So this implies 3 into 2 minus 3m minus m plus 1 0. So this implies minus 10m, and this is 6 minus 1 5, this is minus 5. So m is going to be half. Clear? 6 minus 1 5 taken on right side, so m is going to be half. And you got the value of V1 now. They have asked you to find, so V1 vector going to be what? V1 vector here in our calculation, V1 vector is m into 3i minus j, and m you got here, m is half. So 3i minus j by 2. Clear? Now they have asked to find mod V1 square plus mod V2 square. V2 also you got here. V2 is what? You put the value of m. V2, m value is what? Half. So V2 in this vector V2 you put m equal to half. So V2 is 2 minus 3 by 2, that is half I, that is 3 by 2 j and minus 3k. So mod V1 square plus mod V2 square going to be 9 by 4, 1 by 4, 1 by 4, 9 by 4 and again 9 by 4. So 28 that divided by 4. This is equal to, just a minute, and this is not equal to 9 by 4. See, V2 square, it will be 9 only. Okay, so this is going to be 18, 20 by 4, 5 plus 9, that is 14. Okay, so which option going to be correct? After this session with me, you should try in your own way also. I have done it, I am doing it here. No idea of doing before this session that how to minimize this sum. You got some idea from here from me and you should try on your own. Okay. For this one it is given C is the unit vector perpendicular to plane of, not perpendicular, in the plane of vector A and B and perpendicular to vector E. See the condition given, unit vector given, and C is the unit vector, it is told, and it is in the plane of vector A and B. The plane which contains two vectors A and B, the plane which contains two vectors A and B can be determined with the vector A and B. So the vector C can be taken in this form. Let C equal to, here there is a trick, you can take this C vector lies in the plane of A and B. So you assume that C equal to, there is a trick, you can take C equal to XA plus YB. If you don't want to take two unknowns X and Y, you take C equal to lambda into A plus B. So two options are there. You decide with what option you want to continue. Definitely if you take one variable, calculation will be easier. So you take lambda into I plus 2j plus k plus B vector is 2i plus j minus k. So this will be 2 plus lambda into I, 2 lambda plus 1 into j plus lambda minus 1 into k. Okay, and it is given that C is perpendicular to A. I have taken this form. So C dot A going to be equal to 0. So this implies lambda plus 2, you take dot product with the vector A, plus 2 lambda plus 1 plus lambda minus 1, 0. So 4 lambda minus 2, lambda going to be equal to minus half. So if lambda equal to minus half, then the vector C, if you put lambda equal to minus half over there, C can be taken in the form 3 by 2 I cap 2 lambda minus 1, that is 0 into j cap plus lambda minus 1 minus 3 by 2 k cap. Clear? Therefore, such a vector can be taken 3 by 2 I minus k. Now the problem is no 3 is given over there. What to do? How to decide it? I minus k, you can take plus minus over there. That will not be a problem here. But the thing is that it is not given in this form 3 by 2. So what to do? Now, C vector is some scalar multiple of I minus k. Since C is in this form, so C is along I minus k. C is along I minus k. So a vector along I minus k is going to be what? We write the unit vector first. This is root 2. And we can take plus minus over there. A vector along I minus k, even if you can start from here also. That unit vector is I minus k plus minus root 2. And they have asked you, then such a vector C. C is the unit vector given. So why you don't take this form? And you take minus sign over there. So the vector C can be taken as 1 by root 2, take minus sign over there, minus I plus k. I told you, plus minus both can be taken. It doesn't matter. Clear? Hope you have understood. So option A is the correct one. A and B and two vectors of the same magnitude such that this thing equal to root 2 plus 1. Then you have to find the value of this thing. Mod A plus B whole square by mod A square. How to? So what you can do here that use the given condition first. It is given that mod A equal to mod B. Okay? And then what? You try to get a relation between two vectors. How to? It is given their modulus. But with modulus, if we just put 1 over there, we can use component and dividendo by componendo and dividendo. What do you get? Mod A plus B plus mod A minus B, and plus this thing, mod A plus B and numerator minus denominator, plus mod minus mod A plus B plus mod A minus B equal to root 2 plus 1 plus 1, root 2 plus 1 minus 1. So these two get cancelled. This is going to be 2 into mod A plus B, 2 into mod A minus B, root 2 plus root 2 by root 2. So this implies that mod A plus B is equal to root 2 plus 1 into mod A minus B. Now only one condition is over there, that mod A equal to mod B. Okay, and this you got here, mod A plus B equal to root 2 plus 1 into mod A minus B. So what you can do here? Does it give any specific relation over there? A and B you can bring back if you make square of two sides, and that A plus B whole square you can write in the form A square, B square, twice A dot B. No vector is there. Left side is scalar, right side is also scalar. In the class I have explained how this can be reduced to this. You write this as A plus B dot A plus B. Then simplify it and dot product commutative, so you get this one. So making square of both sides is one step. So you make square of both sides and don't transfer it on the right side. Keep it in this form. Squaring both sides, take from here. Squaring, we get A square, B square plus twice A dot B by A square B square minus A dot B will be root 2 plus 1 whole square. Okay? Your problem is to get this one, mod A plus B whole square by mod A square. Okay, you know mod A equal to mod B, so it will be 2A square and this will be 2A square cos theta. Why? Because since mod A equal to mod B, so you can use this, and that divided by 2A square minus 2A square cos theta is, this is 2 plus 1, 3 plus 2 root 2. Okay? So this will be 1 plus cos theta by 1 minus cos theta 3 plus 2 root 2. But the problem is that you have to get this ratio, mod A plus B whole square by mod A square. Now mod A plus B whole square by mod A square is what? This is nothing but A square B square 2AB cos theta, and here you get only A square. A square equal to B square, so you write 2A square cos theta by A square, 2 into 1 plus cos theta. Okay? Now, if you get the value of cos theta here and substitute, then this is fine. But how to get cos theta over there? You just cross multiply and get the value of cos theta and substitute over there. So this will give you 1 plus cos theta. You can use the component dividend again. So this by this, if you apply, it is going to be 2 by this minus this, 2 cos theta is 4 plus 2 root 2 by 2 plus root 2. 2 plus 2 root 2, sorry. 2 plus 2 root 2. So these two get cancelled. Cos theta going to be 2 into root 2 plus 1, and here if you take 2 root 2 as common, this is going to be root 2 plus 1. So this is 1 by root 2. Isn't it? If you take 2 root 2 common, then, so just put a value of cos theta over there, 2 into 1 plus 1 by root 2, the value is 2 plus root 2. Is that clear? Hope you have understood. So option A is going to be correct. Okay? For this one, it is given C vector is such that A minus C cross B equal to this, A dot C given, B cross C given, then mod A dot D is what? D has link with B cross C because D equal to B cross C. A and B given over there. So, if you use the given condition, from here you can see that A cross B minus C cross B equal to 89 minus 3J plus 12K. Okay? A and B are two given vectors, you can simplify it. From there, you can get minus C cross B, B cross C can be found out. Let us find A cross B first. A cross B is what? I, J, K, and this is 2 minus 3, 1, 3, 2, 5. So I into minus 15 minus 2 minus J into 10 minus 3 plus K into 4 plus 9 minus 17I minus 7J plus 13K. A cross B you got. You can substitute there. From this equation you get minus C cross B equal to minus 18I 3J 12K plus 17I plus 7J minus 13K. So this will be minus I plus 4J minus K. So you got minus C cross B in this form. D is what? D vector is B cross C. This is I minus 4J plus K. Okay? So D vector you got. A vector you know. You can easily find it out. D. So A dot D is what? You just put A and D over there. That is 2I 3J plus K dot D vector, that is I minus 4J plus K. So this will be 2 plus 12 plus 1. This is equal to 15. Alright? So the answer is 15 over there. Clear? Hope you have understood. This question looks bit tricky. Two unit vectors A, B, B sin inverse root 65 by 9. The vector C is given this way, 9C dot A minus 3C dot B. But note, this one is the unit vector and this one B is also unit vector. Now the question is that if we multiply, if we wish to find this result, that C dot A minus C dot B, what problem we are facing? Let us find this part. C dot A cap, this is going to be 3 A cap, 6 B cap, 9 A cross B, and this whole thing is taken dot product with the vector A cap. If you open the bracket 3 A cap dot A cap, this will be 3. This will be 6 into B dot A. B dot A, here theta given, angle between the vectors given, sin theta given as root 65 by 9. When you take dot product with the vector B and A, then it will be 6, 1, 1 because they are unit vector multiplied by cos theta. Now a problem arises, what is the value of scalar trivial product? You haven't done. It is not there in syllabus, but you have a concept in your mind that A cross B is a vector which is perpendicular to the plane of the vectors A and B. You will be using this concept only. This is A cap, B cap, A cross B is perpendicular to both A and B. This you know. So definitely the angle between A cross B and A going to be 90 degree. So this product is vanishing. The result going to be 3 plus 6 cos theta. So C dot A cap you got. What about C dot B cap? C dot B cap going to be 3A cap, 6B cap, A cap cross B cap, and take dot product with B cap. So A cap dot B cap plus 9 A cap B cap, then with B cap. Now this thing going to be 3, again the same manner, 1 into cos theta plus this is mod B whole square 6 only, and this part is 0 because this time A cross B perpendicular to the vector B, result has to be 0. So you got the value of C dot B cap, okay, which is nothing but 3 cos theta plus 6. Now you are supposed to find 9 C dot A minus 3 C dot B. So this is going to be 9 into C dot A, the result you got here. This minus 3 multiplied by, so this is 27 minus 18, 9, and 54 minus 9, 46 cos theta. Okay, 27 minus 18, 27 minus 18 is 9, then 54 minus 9, that is 46 cos theta. This is going to be 45, not 46, 45 cos theta. Okay. Now sin theta value is there. Sin theta is root 65 by 9. So cos theta going to be what? Under root 1 minus 65 by 81. So 9 plus 45 into 81 minus 65, 16 by, that is 4 by 9. So this is going to be 9 plus 20. This is 29. Part B is the correct option. Okay.